All right, so today we are in section 2.3, simplifying variable expressions. Simplifying variable expressions. A couple terms you need to know first, and we're basically, with these terms, we are breaking down each one of them, all right, or each term within an expression. So terms are separated by operations. Like terms can be simplified together. Constant terms are just the number by itself with no variable, and coefficients are the number portion of a term with a variable. We'll talk more about each one of these in the next slide, but for now, just kind of jot down these terms real quick. All right, so in example 1, we're going to identify each part of the expression. So this would be a pretty common question that you would see potentially on a quiz or a test, where you're going to break down what are the terms, what are the like terms, the constants, the coefficients, and then at the very end we're going to simplify. All right, so let's start at the top. The terms. Remember, it's each term that is separated by an operation. So it might have one number in it, a number and a variable. It could have an exponent, but that entire unit would be what we call the term. So we separate the terms when we're listing them like this with commas. Do you see how I used commas? But here's what we do need to remember. If the term is negative, we must include the negative. That's not necessarily a subtraction sign as much as it is the sign of the term. Right, now, like terms, we're going to group our terms with the same variable together and then our terms that are just numbers together. It doesn't matter which one comes first or even what order you write them in the parentheses. All that matters is that you group them together accurately and you include the sign. Because 5y was negative in the original expression, it must be negative when I list the like terms. Same thing with the numbers. Because 3 was negative in the original expression, it has to be negative here too. Constants are just the numbers that stand alone, so 8 and negative 3. The coefficients, I now am going to focus on the terms that have variables. The coefficients are just the number, not the variable part of that term. So let's start with 5. Is it 5 or negative 5? Guys, it's negative 5. Exactly. So I've got to include that negative if it's negative in the original expression. And then let's look at the term y up here at the top. Okay. I don't see a number in front of it. However, if there's no number in front of it, it doesn't mean it's a 0. It means it's an understood 1. It's an understood 1. So the understood 1 needs to be listed as a coefficient. All right? And that's very important too when we're simplifying an expression. We have to remember to add or subtract that 1, that understood 1, to simplify. All right, so speaking of simplifying, here's what I want you to do for all of these problems. I want you to group your like terms together. So we're going to use the commutative property to rearrange the terms in this expression to combine them. So y minus 5y plus 8 minus 3. We can put these even in parentheses if we wanted to help us group them off, but we don't have to. Okay, so y minus 5y. We just talked about the fact that what is understood in front of the first y? What's understood? A 1. So if there's a 1 understood here, what is 1 minus 5?
Negative 6.
Not quite. 1 minus 5 would be negative 4. Negative 4y plus 5. Why plus 5? Why not minus 5? Because what's 8 minus 3? 5. It's positive 5. If it was negative 8 plus 3, it would be negative 5. So we just have to be mindful of our signs. I want you to go ahead and try the second one on your own, and we'll go over it in just a minute. Everybody together, what are the terms of this expression? X, negative 4, 3x, negative 7. What are the like terms? X, and 3x, and -7. Very good. What are my constants?
-4, -7.
-4 and -7. What are the coefficients? 1 and 3. So we do need to remember it's only the number part, not the variable. And when we simplify, what did we get?
-7x.
4x minus 11. 4x minus 11. Who got 4x minus 11? Okay. All right. Moving on to the next example. Simplifying an expression. So the rest of the lesson, we're really going to just spend focusing on combining these like terms. So the first step in doing that is to use the commutative property to reorder the terms and group my like terms together. All right, so it doesn't matter if you want to group your n's first or your numbers first, but you need to group them together. So what I'm going to do is start with my variables, 4n minus n. You see what I did there? I took my n terms and I grouped them together, but I have to keep the sign that's in front of the term in the original. So since n was negative in the original, I keep it negative. So what's going to be my next two numbers after the n? -7 plus 9. Now I can combine them. 4n minus n would be not 4n, because what's understood to be in front of the 1? A 1, so what's 4 minus 1? 3n. What's -7 plus 9? 2. 3n plus 2. 3n plus 2. All right, I want you to try B now. So use the commutative property. When you copy it down on your paper, you should be grouping your like terms together so you can simplify. Okay, so on B, I group my x's. What's 8x plus x? 9x. And what's 22 minus 10?
12.
All right, who got 9x plus 12? Okay, so now we're moving. All right, now on C, 3x minus x, -4x plus 4. Who got -4x plus 4? All right, good. Okay, so that's it for example 2. Now on example 3, I have distributive property. So I've got these parentheses. It's no big deal. Okay, I just need to get rid of them first. And I do that by multiplying the number on the outside by every term inside the parentheses. So 2 times x would be
2 times 2.
2 times x would be
2x.
2x. Okay, go ahead and write down the original expression and we'll work through the distributive property. All right, so 2 times x is what, guys? We just went over it. 2x. And then 2 times -4 is -8. And then we bring down the rest of the expression. So now we've gotten rid of the parentheses, and now we can simplify our terms. Well, we want to put them in order. So 2x plus 9x minus 8 plus 1. What's 2x plus 9x?
11x.
11x. And then what's -8 plus 1?
-7.
-7. All right. I want you to try to do B. Try B. Do the distributive property. Did you distribute the -8? Did you see that it was negative? 8 is negative, so what's -8 times k? -8k. What's -8 times +2? -16. You say, well, when you say it that way, it sounds easy. Yeah, but that's how I want you to read it too. All right? So we treat the 8 like a negative because it has one in front of it. All right, so that's my final answer, right?
No.
Why not?
Because you still have to.
I can still combine my like terms. What's 3k minus 8k? -5k minus 16. All right, so now let's look at C. What's different about C is technically the way that it's written, it really doesn't need parentheses. Right? I mean, it's not separating a double sign, but because the parentheses are there, It's indicating to us that there is, in fact, an understood 1 in front of the parentheses. So if you ever see a minus sign in front of parentheses, there is actually an understood 1 in front of those parentheses. And we have to treat it like that. So it's going to be 4a. And then what's negative 1 times 4a?
Negative 4A.
Negative 4a. And what's negative 1 times negative 3?
Negative 3.
Positive 3. All right. So is that my final answer?
No.
All right. What would be my final answer? Write it on your papers. Don't say it out loud. What would be my final answer? All right. Who says a plus 3? Anybody say a plus 3? That's a common answer. Who would just say 3? The answer is just 3 because 4a minus 4a actually cancels. Anybody know what number property that would apply to?
Inverse.
The inverse property of addition. Take any number term and its opposite, and the answer is 0. So my final answer will be 3. So if you forgot that and just said a plus 3, that's actually not correct because the a's cancel. All right, one more example, example 4. In example 4, we're finding perimeter. So yesterday we found the area using distributive property. Now we're going to find the perimeter given the following dimensions: a length of 7y minus 5 and a width of 2y. Well, we know that what type of shape is this? It's a rectangle. So do you remember the formula for the perimeter of a rectangle?
2L plus
2 times the length plus 2 times the width. I want you to make your substitutions now, knowing your dimensions. Make your substitutions into the formula and make sure you include parentheses around the substitution. Okay, so we make our substitution 2 times 7y minus 5 plus 2 times 2y. Now we need to distribute. Did you do that? Have you done that yet? Okay, so 2 times 7y is what? What is it? 14y. 2 times negative 5? Negative 10 plus 4y. But this isn't our answer.
You have to.
Because what can I still do?
14.
I can still simplify it even more. What would it be? 14y plus 4y or minus?
Plus.
It is plus because of the plus sign in front of the 4y. It's positive. They're both positive. 18y minus 10, and it's units. You would just label it units.
And now we're done.
And now that's the answer for perimeter.
Isn't it 2, like, squared?
It's not squared because we didn't find area, we just found perimeter. Y'all ready for the last one? Triangle. Does anybody know the perimeter of a triangle? A plus B plus C. Does it matter what order I add them in?
No.
It doesn't. Okay, so go ahead and make your substitutions into the formula and then combine your like terms. Right, so we can start wherever we want. P equals 2x plus 3x minus 2. Well, what's 2x plus x plus 3x?
6x.
Is it 5x or 6x?
6x.
Did you get 6x?
Yes.
Gotta remember the 1. There's the understood 1 right here. 2 plus 1 plus 3 is 6. Okay? So remember, that x is still 1x that I have to add. 6x minus 2 units would be my perimeter. And if you understand that, that's everything you need to know for section 2.3.
I used to always